Hello everyone, welcome to Dr. Ravi's Academy. In today's virtual class, we will be understanding the important theorems of moment of inertia. You have two theorems, one is a perpendicular axis theorem and the other one is a parallel axis theorem. Now, let us understand these two theorems. Perpendicular axis theorem, which is also known as polar moment of inertia, and parallel axis theorem, which is also known as the transfer formula. So let us first discuss perpendicular axis theorem. Let us consider the given area in first quadrant. Let us consider XOY, and you have an area A. Let us select an elemental area dA at a distance y from the x-axis and x from the y-axis and r from the z-axis. This is also z-axis, r from the z-axis. And let us write the expression for the moment of inertia about x-axis. I am writing it as Ix is equals to, it is a moment of area, that is integral y square dA. And about y-axis, that is Iy is equals to, it is a moment of area, that is integral x square dA. Now let us write down the moment of inertia of this particular area which is in xy plane about an axis perpendicular to the plane, that is about z axis. Then the distance becomes r. You can write down it as Iz is equals to, it is integral r square dA. But you know that it is r square is hypotenuse of this right angle triangle. You can replace it with x square plus y square, and you can write down it is x square dA plus y square dA integral. So this is nothing but Iz is equals to, it is x square dA is nothing but your Iy, and this is Ix. You can write down it is Ix plus Iy. So the moment of inertia about an axis perpendicular to the given plane of area is the sum of algebraic sum of the moment of inertia of that particular area about a perpendicular axis in the same plane. So this is also known as polar moment of inertia, represented with a symbol J. It is polar moment of inertia is nothing but moment of inertia about an axis perpendicular to it. So this is what the first theorem, that is perpendicular axis theorem. Now let us look at the parallel axis theorem. So let us understand the parallel axis theorem. Let us consider an area A and a centroid, horizontal centered axis, I am calling it as XC, and a horizontal axis X. The distance between these two is D, right? This is the centroid C, and let us select an elemental area dA at a distance YC from the centroid and at a distance y from the x-axis. Now write down the expression for the moment of inertia about x-axis, which is equals to its integral, it is y square dA. So but y, this y you can replace with the yc plus d. So you can write down it is yc plus d whole square into dA. Let us expand this. That becomes Ix is equals to, it is yc square plus d square plus 2ycd into dA integral. So this you can write down. It is integral yc square dA plus integral d square you can keep outside. It is integral dA plus, you can write down 2d you can keep outside, integral yc into dA. Observe carefully here, yc square dA is nothing but it is moment of inertia about central axis, that you can write down Ixc, central moment of inertia, plus this is integral dA is nothing but A, it is A d square. So this value, moment of area about its own axis, will be 0. So this particular theorem is known as parallel axis theorem, and among these two parallel axes, one must be the central axis. Then only you can apply this particular parallel axis theorem. This is also known as familiarly transfer formula. Thank you very much for watching this particular video. I hope you have understood this both the theorems very clearly. Thank you.